Okay.
Okay. Why do you think that inverse operations has been used in so many textbooks? And what is the mathematical definition of substitution? I don't know if you want to do those separately or.
Yeah, no, so the last one is easier. There's no mathematical substitution of definition of substitution. The substitution simply means you have you have an equation, and you have a term here, which could be anything, and then by a different calculation, you found that this is equal to something else. Then, well, you have a different expression for this quantity, the equal, so you can just put this into this expression if you want. So you just do it. I'm sorry?
Can you call it a transitive property, that substitution?
Yeah, I guess strictly speaking, you say if A is equal to B, B is equal to C, then A is equal to C, right? Yeah. But that's something you just mention once and forget. I mean, it's not something you want to linger over. So now I don't think there's anything formal about substitution. We just do, it's the sort of thing you just do without thinking. But the other one, what's the other one?
Why do you think that inverse
Right. Well, I mean, you see, this morning we talked about so many mistakes in textbooks already. So, I mean, there's no explanation for why our textbooks are so bad. You know, it's one mistake after another. It's basically it. Other than what I told you from the publisher, what I heard from the publishers. They are determined to write books that every teacher would say, I know that, I'm comfortable with it. They are not going to write anything that's correct, no matter how wrong the present version is. Because if you do that, teachers would say, I don't recognize this. They don't adopt it, because they know that adoption is a very local thing by a committee of teachers. Teachers don't adopt it. For whatever reason, they are out of business. And so as I said, I learned this only about a year ago, or less than 10 months ago. So the only hope of getting better textbooks is that our teachers begin to raise the bar and say, we're not going to put up with this kind of low-level mathematical exposition. Then they respond. They always do. Where money is concerned, they always respond. Until then, I don't think there's any hope.
Okay, this one said, clearly explain the names for standard algorithm versus exponential versus expanded form when we are expected to do what? I think there was some confusion.
Yeah, I think that was what happened yesterday when I thought you all understood that I was only interested in the explanation because I took for granted that you could do all the algorithms and I wasn't going to talk about it. So every time I say do this and that, the emphasis would always be on explaining what you're doing. So I didn't make that clear, but in the future I will, so just to make sure that everybody is on the same page. As to the using exponential notation, that really is for clarity. You can see it. I mean, if you say you're talking about, you always emphasize single digits. So if that's what you emphasize, then obviously take a number 5760, let's say. So you say the 7 really is 700. That, of course, is correct. But then in the subsequent computations, if you tag this along, then you don't show all the fact that you're always dealing with 7 and never mind the 0, 0. So therefore, this morning you saw too much of it. I'm not going to repeat myself. But if you do it this way, right? Then in the computations, you focus on, zero in on the 7. And then you saw the display. It was always just that single digit. So it's clarity. That's all. Right? Nothing more than that. Yeah, so I hope that's enough.
Can you review the parentheses and bracket notation? I don't like the double parentheses.
Okay. Now, in fact, I was going to point it out to you this morning, and I forgot. Remember, in the explanation of whatever the division was, 876 divided by 6 and so on. And at some point, I had about 4 sets of parentheses. I was going to tell you, look. I had an interesting experience with an editor. So I wrote something, and I used because I thought. So I had something of this nature. I forgot. -1, and then I said minus something of nature. I forgot something like that. Yeah. And so I used braces. And she wrote back and said, "You sure that's what you want to do?" I said, "What about this?" So I said, well, I thought this was more clear, that people would find it more acceptable. And she said, you should find out. So I talked to 2 different sets of people. Did I talk to you, Wendy? No, not you. Anyway, I talked to two different teachers, and the reactions were different. One was that, well, this is much easier, everybody accepts it. The other says, well, actually it's more clear and we like that better. So I don't think there's any consensus on this issue. What about you here? That's what I want to know. Maybe we should do a click. Yeah.
Does that everybody do the brackets?
Do the square bracket.
Oh, square, okay, all right.
Is there a difference?
No difference at all. Okay, 1, 2, and 3. What do you think is, how do I phrase it? Which do you think is most clear, I guess?
Are you ready?
Okay, 1, 2, 3.
Do you want to have an answer that says it doesn't matter? Or is that not?
Okay, doesn't matter. So 4 is,
Or just pick the one you like the best.
yeah,
So that way I don't have to
yeah,
say it.
yeah.
Isn't part of the point of saying if we don't think it matters at all, I'm not saying
Okay,
anything?
all right, hold on.
Doesn't matter.
All right, well, if you want. Okay, we could make it.
Now I read it, so you have to review everything if you already.
Okay.
We're up to 4. We have 4 choices.
Wow, everybody, nobody likes the first?
Well, the first one, that reminds me of one.
Is that what you expected? Is this what you expected? That's shocking.
You know what, these are easier for people to
The curly one. So it's like, done with this.
Okay, no wonder the editor asked me. Okay, so square brackets are good. Okay, I'll remember that.
We've had this discussion in a math class that I recently took about the hierarchy of the brackets. And
Oh, there's no hierarchy.
right, but one of the other comments was that other than the parentheses, the brackets and the braces have other meanings in math when you're describing sets and things. And so that we talked about using the parentheses to eliminate confusion, just because they mean something different.
Not among mathematicians, I can tell you that. We use whatever comes handy.
That's funny.
I'm sorry, Leah?
I just like the third one because it's easier to scan through a long line of text and figure out what's being bracketed, where the groups lie. If I'm looking for parentheses, I can get. Yeah, I'm like, this is the third one.
Oh, you're looking for this, you mean?
No, number 3.
Number 3.
Yeah.
No, you mean this? You have the count.
2 is confusing.
Yeah, 2 is, I know that. So sometimes I can make bigger ones.
Yeah.
Sometimes I can make bigger ones.
But in print, you can't.
But I thought this was the most clear because this, you see, well, I don't know what depends on the typesetting, I guess, but in the software I have, it doesn't stand out. I use it quite a bit somewhere, I don't know where, and you see that it's almost the same as this.
It's the same size, whereas the
Yeah.
printers are much bigger.
And this, it stands out right away as something different. But if you don't like it, you don't like it, I'm not going to use it. Right? Okay, that's good. So now I know.
I think it has to go with meaning. That what she said, that very often you see that in terms of sets, and so when you look at that and you go, is he talking about a set? What's going on?
All right.
You're all like, something different's going on here. Whereas the square brackets are very common use in English all the time too.
Yeah. Yeah. Okay. Is that all? Really? That's it. Okay. So you would like to? Let's see. Can we do this in a snappy way? I give you a problem of this division kind. If you promise to do it in 10 minutes. Okay. You promise first, and I write it.
Do you sign a contract with that reader?
Oh yes, in blood.